All right, so we're going to utilize this information that we just wrote down to do a little problem. And this is a whole different type of a problem about pushing a non-spontaneous reaction through. We want to calculate the grams of aluminum produced in 1 hour, take note of that, 1 hour, by electrolysis of aluminum chloride. That's an aqueous solution. If the current that we're applying is 10 amps. All right, so it sounds terrible, but it really is not as bad as it sounds. Let's go ahead and just punch some of this information through, and we're going to be looking at this equation up here. When I say up here, right here, and then we'll move forward from there. So I have the current, I'm sorry, the amps, which is 10 amps, and I have an hour, but based upon what we were looking at with the units, that needs to be in seconds. So I'm going to change that over to it's just some really quick math here. 3,600 seconds per 1 hour. I know you're impressed, but yeah, I was able to do that quickly. And that turns into 3.6 times 10 to the fourth coulombs. All right. Now that I have coulombs, I can take a next step because ultimately I need to get to grams. So I can do this with Faraday's constant. So I have the coulombs, and I know there's a relationship between coulombs and electrons. 96, and I'll just round up, 500 coulombs for every 1 mole of electrons. This is the charge on a mole of electrons. Doing that, I have 0.373 mole of electrons that I'm going to be applying over to aluminum. These are the electrons that aluminum is going to be taking in. Now, I need to analyze what's going on or what will go on with aluminum. Like a reduction equation, aluminum requires 3 electrons to transfer from the aqueous solution, aqueous aluminum, over to aluminum metal. So if I take the value I had previously, 0.373 moles of electrons, and I'm dealing with 3 moles of electrons for every 1 mole of aluminum metal, solid. That'll give me 0.124 moles of aluminum. Fantastic. I'm not done. One more small part left. For every 1 mole of aluminum, I need the molar mass, which happens to be ballpark 27 grams. So in this process, we can actually produce 3.36 grams of aluminum. Pretty interesting. All right, let's do our last homework problem and call it a day. Here's the problem, number 94, very similar problem. Elemental calcium is produced by electrolysis of molten calcium chlorides. We take this out, we get up to a high enough temperature that the ions are floating around freely. What mass of calcium can be produced by this process if a current is blasted through there for 48 hours? Okay, very similar problem. We've got the equation, which is going to be charge based upon the amps and the time. So if we apply this, we have 7.5 times 10 to the third amps, and again, pulling this right out of the problem, times the time, 48 hours, times 3,600 seconds, for every 1 hour. And that'll give me, there's something else in here I had to pull out. Oh, the efficiency. Assume that the efficiency of this process is only 68%. I can apply this anywhere in the problem, but I'm going to throw it in right now. So whatever answer I get, I didn't get it all. I only got 68% of it. And the value that's going to come churning out is going to be, I'm going to write it down here just so I can continue. 8.81 times 10 to the 8th coulombs. That's all I was able to capture in this process. And again, looking for an answer in charge. If I take this value, multiply times Faraday's constant, 96,000, roughly 500 coulombs per 1 mole of electrons, the answer I will get is 9,133 moles of electrons. And if I'm focusing on calcium, it's 2 moles of electrons for every 1 mole of calcium. And what did I do there? 1 mole Ca. And just to keep plugging this through, for every 1 mole of calcium, I will have 40 grams. That's the molar mass. And that'll give me a final answer of 1.8 times 10 to the 5th grams. It's quite a bit of calcium that comes out of that molten mix. All right, let's finish it up. What is the minimum voltage needed to cause electrolysis? In other words, to push this non-spontaneous reaction forward. Well, let's find out. Calcium 2+ is reduction, gaining electrons to give me calcium metal. And we're saying that this is going to, we already are signifying this is the thing that's going to be gaining electrons to happen based on the electrolysis, getting the calcium metal. So I know that's going to be gaining electrons. The other stuff in here, the chlorine, for its reduction potential, and again, I know this doesn't work. It's an electrolysis reaction. We know this is going to be the anode. It's losing electrons, so I would have to be careful if I was doing this because I'm going to be creating some chlorine gas. Usually not too cool. Now this is gaining, this is going to be the cathode, and this is going to be the anode. So for the cell, if I pull up the numbers for these out of the table, it's going to be a negative, that's for calcium, 2.87 minus 1.359 is equal to negative 4.23. That's a pretty low or large negative value, which means that's very non-spontaneous. So therefore, we have to apply that much energy. To make this go forward. That's it. That's the end of the lecture.